In this question, we're asked to solve two system of equations problems using the elimination method. So let's start with the first equation the first system over here. And just to be a little bit more organized, let's just call this our first system over here, and then our second system, so we don't get confused by which one is which. All right, so to solve a system of equations by elimination, our goal is to eliminate a variable. And it doesn't matter which variable we choose to eliminate, but we usually tend to eliminate the easiest variable, which makes sense. So in this system over here, we have negative 4x and an x. If I wanted to eliminate the x's, I could multiply this bottom equation by 4. So let's do that right now. I'm just going to pick a different color. How about, let's do blue. So I can multiply this entire bottom equation by 4 to eliminate the x's. Now, I don't have to eliminate the x's. If I wanted to, we have a negative 3y here, so I could eliminate the y's by multiplying this bottom equation by negative 3 to give me a negative 9y, and then the 9y and then the negative 9y will cancel out because you're adding the equations together. So now we have canceled out the x's, so rewriting our top equation, we have negative 4x, let me fix that x, negative 4x plus 9y equals 0, and then 4x minus 12y equals negative 24. Make sure to multiply the 4 through both terms and on the right side of the equation. Now when we add the equations together, negative 4x and 4x cancel each other out. 9y minus 12y simplifies to negative 3y. And 0 minus 24 is just negative 24. Now when we divide both sides of the equation by negative 3, we have y equals negative 24 divided by negative 3 simplifies to 8. So now that we know that y equals 8, we can plug an 8 back in for x in either one of the original, plug a 8 back in for y in either one of the original equations. Let's go with the first equation here. The first equation then becomes negative 4x plus 9y, which is 9 times 8 equals 0. So we have negative 4x plus 72 equals 0, or negative 4x equals negative 72. Divide both sides by negative 4. And on a calculator quick, I'm just going to do negative 72 divided by negative 4. It gives me 18. So we have x equals 18. So our solution to our first system is 18, comma 8, which we write as the ordered pair 18, comma 8. We can check that by plugging an 8 and an 18 back into the original equation. And we get x is 18 minus 24, which is negative 6. All right, so now we can solve our second system here. Doesn't matter what variable we choose to eliminate. Let's eliminate the y's. You would definitely want to eliminate because we already have a positive, or we only have to multiply the top equation by negative 3. If we eliminate the x's, we would have way more work to do. So let's just multiply the top equation by negative 3. Now that gives us 21x minus 3y equals negative 19 times negative 3. Negative times a negative is a positive. 20 times 3 is 60, so 19 times 3 is 57. We have negative 2x plus 3y equals negative 19. Now when we add the equations together, the negative 3y and positive 3y cancel out, and we have 21x minus 2x, which is 19x, equals 57 minus 19, which is 38. 38, yep. Now we can just divide both sides by 19, and we have x equals 2. Now that we know what x equals, we can plug in a 2 back in for x in either one of the original equations. It does not matter. So let's go with the second equation here, because why not? Now if we plug in x, we get negative 2 times 2 plus 3y equals negative 19, or negative 4 plus 3y equals negative 19. And adding 4 to both sides, you get 3y equals negative 19 plus 4, which is negative 15. Dividing both sides by 3, we get y equals negative 5. So our solution for this problem is going to be 2, comma, negative 5. And that is our ordered pair. So I hope this helped you.